Okay, getting back to our discussion of polynomials, if you take a look at some of these ones here, and here are several examples, you'll see, the exponent on this one here is a 1, the exponent on this one here is a 2, here's a 5, and of course they're ordered in such a way that it's decreasing as the exponents get less and less. So if I have the largest one here, you can see here that this will be exponent of 1, here's an exponent of 2, 5, etc. Same thing down here. There's a difference though between the number of terms and degree of a polynomial. If you take a look at these ones here, well, first of all, how many terms are just simply count them. And so it's pretty easy and straightforward. So you're going to see here that there's 3 here, 1 term, 4, and 5. But the degree is what the exponent says the highest one here. So you can see here that it's going to be 2, 3, or 5. As we keep going now, that's just basic classifications, but as we keep going, we're going to talk about if functions are symmetric. And if you take a look at this one here, you'll see here, this one actually, I'm going to deal with this one first. The parabola, the regular quadratic here, you'll see what happens here is as this reflects, okay, it's like a mirror image, and it reflects around the y-axis, here it comes up over here. And so it's like there's a mirror right here. It's like this is a mirror. And you can see that it reflects around here. And so we would say that it reflects around the y-axis, or the axis of symmetry, I call it, is around the y-axis. Same with this function here. If you take a look at this one, it's almost like it just did a complete flip from the y-axis. Now, another origin that another symmetry that you should be aware of is when it reflects around the origin. And if you take a look at this one, it's almost like it flipped, it's almost like it flipped around here and had a mirror image around the y-axis, and then again around the x. So it's like it flipped twice, or what we could say is really it just did a 180 here. Okay, it just basically did a 180. Let me just get this rolling here. So it basically just flipped like this, and so it's almost like it did a complete 180. Same thing with this one. It's almost like it did a complete 180, and now it's over here. So they're both symmetric about what's called the origin. Why is that important? Well, first of all, you should know that you can never be symmetric around the horizontal line, or like the x-axis, because if you were, then that's not going to be a function. Okay, so if it is like that, then it's definitely not a function because it's a horizontal line. And last but not least, some classifications here, one of them that we call an even function versus an odd function. Just be aware here that for even functions, they're always symmetric around the y-axis. So if I go back to some of my pictures here, this would be an even function. In fact, this function right here is just f of x is equal to x squared. And you'll see something that maybe why we call them even functions. This one right here is actually f of x is equal to x cubed. And you might see right away why we call them odd functions. It might start clicking in. But if you take a look at these ones here, whether even or odd, the even again are symmetric around the y-axis, the odd are symmetric around the origin. Sometimes they're not even or odd, and that can be a little bit tricky, but something like this, if you look at this graph here, 1, 2, 3, and if I graph this one here, it's not symmetric around the y-axis or the origin. So most functions are actually not going to be even or odd. It's just that rare notation. Usually the parent functions that we're going to talk about, which we're referring to as even or odd. One last thing here is that I'll talk about this more in class, but if you ever want to test if something's even, okay, well, if I put negative x, and I'll just show you this here for this graph. So let's say this function that we had here. If I put f of negative x, notice what happens here. What you're going to get is you're going to get x squared back. In other words, you get f of x back, okay, whether I put negative x or this. And that's because of the symmetry of the graph. That's because no matter if I put a positive value of x or negative, I get the same value for y. But whereas this graph right here, okay, if I put an f of negative x, what you're going to get is, well, negative x cubed, which is the same as negative x. And so because of that, it actually becomes negative f of x. And so this one here, we would say, and in fact, I just see a mistake right here. This should be is odd. Okay, so this would be odd, and that one is even. So I'll just change that. That should be odd, and I'll change that in my site. But just so you're aware here of the differences between the two. Again, I'll talk more about this in class.